In this video, we are going to discuss about another application of derivative. That is, we can use the derivative as a rate measure. Right, so we use it as a rate measure. See, when we talk about rate measure or what we mean by rate measure. See, rate measure is basically that you can say a particular type of application where we are going to apply this in physics, you can say, or in mensuration in different concepts of math and physics, right? So rate measure in the sense something is changing, like you can, if you take an example of velocity. Velocity is where the object is moving, correct? So if you take an example of velocity, velocity is nothing but the rate of change of displacement. See, rate of change of displacement, correct? Now, a very important part here, what you need to understand is you have rate of rate. Rate is basically the derivative application, all right? Or you can also say acceleration, rate of change of velocity. Now, mathematical formula is going to be a bit different. So, if you're writing velocity, v is equal to d by dt of s being the displacement. So in this case, what you see here, a rate of change is there, correct? So d by dt represents the rate of change. So d by dt of s, that's basically rate of change of displacement. So we can use the derivative or the concept of differentiation in understanding how a particular parameter is changing. Okay, so when I say change, the change can be in any particular magnitude, any particular direction. It can be in any format. All right, like for example, if you take area, let's say a balloon. Okay, so say you're going to put air inside the balloon. Volume is increasing, surface area is increasing. So with what speed you put the air inside with the balloon, the area increases in that particular fashion, like in the sense how fast or how slow, right? Or the change in the volume also. More the air you're going to put inside, more is going to be the volume. In the sense, the rate of the increase in volume, whatever we are looking at, that is an application of the derivative, or you can say application of differentiation. That is what we are going to study in this particular part of the chapter. All right. So, like I'm giving you some different examples, mostly we are going to talk about physics point of view, where you have the velocity part, acceleration part, and other things also. All right. Along with that, the most number of problems what you have is mensuration problems, where the volume is changing, surface area is changing, or some other parameter. Like for a cone, volume of the cone is increasing, volume of the cone is decreasing, whatever. So, whenever we talk about two important things are there, or you can say just one important thing. All right, that is, suppose if the rate of change is positive, then the derivative, that is the dy by dx, is positive. All right, if the change is negative, then dy by dx becomes negative. Clear? Like this is for increasing part, this is for decreasing part. Like suppose if I say that the volume of a particular figure is increasing every second or every minute, then dy by dx is positive. Or suppose if I say the bacterial infection within a particular sample is decreasing at a particular rate, dy by dx is negative. This is what we mean by it. Fair enough? So this is the basics of the derivative as a rate measure. Now, there is no like a new concept what you will be learning. It's the same old part whatever you have learned. All right. Now in the next video onwards, we'll directly start with problems. Now there are no certain types of problems. Pretty much all of them are one and the same. You differentiate, substitute the value, get the answer types. All right. So from the next video, we'll start with problems and we'll go ahead and we'll explore different types of problems, and then we'll figure out how derivative can be used as a rate measure.